Okay, more practice completing the square. We have got both of our variable terms, our quadratic and our linear term on the left-hand side. So I am going to write this again with just a little space so I can add something and complete the square. I'm going to start by cutting the 6 in half. I get 3. I square that. I add 9. If you don't remember why we complete the square that way, that's so it'll factor using a binomial square. B plus 3 times b plus 3, I get b squared plus 2 times 3 times b, that's the 6b plus 3 squared. So I've got b plus 3 quantity squared equals 12. I'm going to take the square root of both sides, and we get b plus 3 equals plus or minus the square root of 12. We'll simplify that in a minute. Subtract 3 from both sides. 4 divides into 12. That's a perfect square. Square root of 4 is 2. We get b equals negative 3 plus or minus 2 square roots of 3. 12 is a little different. We notice now our linear term is not an even number. I am going to cut 7 in half. I'm going to leave it as a fraction. You are going to see patterns better if you leave these as fractions than if you convert everything to a decimal, so I'm going to go with the fractions. I'm going to square that. I get 49 in the numerator. I get 4 in the denominator. So I want to make sure that I add that same thing to the other side, 49 over 4. I'm sorry, I changed that to a positive 1. Now when I go ahead and factor this, I got m minus 7 over 2 times m minus 7 over 2. 7 halves squared is 49 over 4. Negative 7 halves times 2 gives me that negative 7 equals, what do I have on this side, 53 over 4. So we got m minus 7 halves quantity squared equals 53 over 4. I am going to take the square root of both sides. We get m minus 7 halves equals plus or minus 53 cannot be factored, but we can take the square of 4 and we get 2. Add 7 halves to both sides. I get 7 halves plus or minus root 53 over 2. Keep in mind, this is two separate numbers. This is 7 plus the square root of 53 over 2, and then 7 minus the square root of 53 over 2. And there are two solutions. Example 13 has a leading coefficient of 2. I'm going to start this the same way. I'm going to move the 3 to the other side by subtracting 3 from both sides. This looks different. I can't make this a perfect square with the 2 out front, so I'm going to factor the 2 out of everything on that side. Now I take a look at my linear coefficient, this negative 4. I cut it in half, we get negative 2. We square that, we get positive 4. But take a look at what I really have over here on the left-hand side. Now I have 2x squared minus 8x plus 8. When I added the 4 inside the parentheses, I really added 8. So I'm going to add 8 on this side as well. And I'm going to go ahead and factor 2 times x minus 2 quantity squared equals 5. And because I write way too big, now I'm going to divide both sides by 2. I got x minus 2 quantity squared equals 5 halves. Square root of both sides, I get x minus 2 equals plus or minus the square root of 5 halves. X equals 2 plus or minus square root of 5 halves. And we're not going to worry about writing that with a denominator and no, we're going to leave it like this. Last thing we're going to do is solve a quadratic equation using the quadratic formula here. Everything is on my left-hand side. So I am going to write these out. A equals 3, B equals negative 5, C equals negative 2, And then I'm going to go ahead and substitute in. So minus b, which is -5, plus or minus the square root. I am wrapping this in parentheses. I'm squaring -5 minus 4 times a times c is -2, all over 2 times 3. -5 is 5, plus or minus the square root of 25. I got minus a negative plus, 24, all over 6. 5 plus or minus the square root of 49, all over 6. 5 plus or minus 7. I got 5 plus 7 over 6. 12 over 6 equals 2. And then we've got 5 minus 7 over 6. -2 over 6 equals -1/3. Because we're getting rational solutions here, we could have factored that. Example 15. So here we have got fractions that if we can, we'd kind of like to avoid working with. So I'm going to go ahead and multiply everything by 4. Because the roots are going to be the same. And now I got m squared minus 4m plus 2 still equals 0. A is 1, b is -4, and c is 2. X equals -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Gives us a positive 4 plus or minus the square root of -4 squared is 16 minus 8. We get 8 all over 2. Four plus or minus 2 square roots of 2 over 2. 4 over 2 is 2, plus or minus the square root of 2.